Today's video will demonstrate the template method design pattern. Hello, I'm James Helfrich. There are three types of algorithm abstraction design patterns: the strategy, the template method, and the decorator. This video will define and show examples of the template method design pattern. There are three types of algorithm abstraction design patterns. The first is the strategy, the second one is the template method, and the third is the decorator. Today, we're going to talk about the template method, which is to define common steps in an algorithm and allowing subclasses to decide what the steps mean. The template method consists of four parts. The first is the client, the second is the template method itself, the third is the abstract template class, and the last is the concrete template. Now, the client is the class that uses the algorithm defined in a template method. The template method is the actual function we're going to abstract, and it's going to call several different steps or phases which will carry out the algorithm. The third is the abstract template class, which is going to contain the template method. And the last is the concrete template, which will define one or more of the steps defined by the abstract template class. So let's take a look at the class diagram. First, I'll remember that we're going to have one action, and that action is going to have several different steps, and each step is going to take the context. Now, the pseudocode is for an action, perform step one, then step two, step three. Okay. Now, the abstract template is going to contain the template method, which step one, step two, step three. And so the pseudocode of the before and after look really similar. Now, in this particular example, step one is not virtual, therefore no one can override it. Step two is virtual, and step three is a pure virtual function. In other words, every derived class is required to override it. And I just included these three types just as an example of the types of things we can do. Okay, now we're going to have our concrete template one, which is going to overwrite step two, which it may, and step three, which it must. And of course, we're going to get this through inheritance. Concrete template two only overwrites step three, which it must, of course, because step three is a pure virtual function. And concrete template three also happens to overwrite step two and step three. And of course, the client's going to use the concrete template class. So this is the client is obviously the client, and the template is the abstract template, and the template method is the single public method that the client can utilize. And we have the steps, in this case, step two and step three. So let's take an example how this could work. We're going to bake. Now, in order to bake, I need to mix the dry ingredients, mix the wet ingredients, combine the ingredients together, and while not mixed, keep mixing it all up, then place it in the oven and keep it in the oven until it is finished. So that's my pseudocode. And this is going to consist of several different functions. So bake is going to first have mix dry, then mix wet, and then combine, and then mix all those ingredients together and place in oven. And I got to know, of course, if I'm finished, and I have to be able to wait. So these are all the different functions associated with baking. Now I want to turn this right here into the template method design pattern. So I'm going to start with a bake class. And the bake class has one public interface called bake, and mix dry, mix wet, and finished. These are all virtual functions. In fact, they're pure virtual functions requiring the client to define them. But the combine, mix, place in oven, and wait, those are not virtual. Those are going to be the same for all the different variations. Now, my bake cake is going to define its own mix dry, mix wet, and finished. And it's going to, of course, inherit off of bake. And then bake bread will also define mixed dry, mixed wet, and finished. And so we'll bake protein bar. Now, sometimes we can make this even more complicated. For an example, I want to bake a cake, bake bread, and bake protein bar. Now let's just focus on the protein bar. And the protein bar defines finished, but does not define the other two. In other words, this is still an abstract class. And how many different kinds of protein bars can I have? Well, I can have a peanut butter bar, a pretzel bar, and a nut bar. But the nut bar only defines mix wet. Okay, so in other words, it's also not finished. The mix dry is not done yet. So this is also an abstract class. And how many different kinds of nut bars are there? Well, we have an almond bar, a pumpkin seed bar, and a granola bar. And these guys are only going to define their mix dry. And they're all these different types of nut bars, almond, pumpkin, and granola, are going to share the same mix wet from baked nut and the same finished from all the other protein bars. And of course, bake is going to have a bunch of other things as well. And this way, I'm going to remove any duplication. If there is something that's common between a collection of different types of baking, it's probably going to be in one of the base classes. So here's another example. A bank account is updated in 3 steps. Apply any transactions added since the last balance, compute interest, and apply any market corrections. Let's take a look at how we're going to solve this problem. First of all, notice how there are 3 steps. And since there's 3 distinct steps, the template method design pattern seems to be a good choice. So we have 3 steps: apply any transaction added since the last balance update, compute interest, and apply any market corrections. So I'm going to have account update, and I'm going to have those 3 steps: add transactions, compute interest, and market corrections. And I'm going to put all these guys in a single class called account update. Now I have cash accounts with checking, savings, and credit. So I'm going to call that cash update, and it's only going to update add transactions and compute interest because there's no market correction for cash accounts. And this, of course, is related through inheritance. Next, I'm going to have my investment accounts, stocks and shares. And this is going to have both the add transactions, compute interest, as well as the market corrections because stocks can change their value. And then finally, I'm going to have my interest computation. And so I'm going to say loan update, and it's not going to have market correction also, but it will have add transactions and compute interest. And each account will contain a reference of account update. This is example 43.2 in the template method section of the algorithm abstraction chapter of the software design textbook.